Hello, my chemistry nerds, my math fiends. Welcome back to your message from deep space. I read a lot of comments on the last episode because I'm now back behind on recording again. So I don't have any of these backlogged. I'm bad. I'm horrible. Thank you to everybody that tried to fix my large recording issue and telling me that, hey, Tyler, in the settings you can turn off all of the things. I've already done that. Okay. There's still the little bubbly nonsense around the screen. Like there's nothing that you can disable to get rid of that kind of stuff. I turned off the scan lines and low blend and all this nonsense. So thank you for trying to figure it out, but unfortunately, I mean, that's just not... I already tried it, okay? A lot of you also hate compound with a burning passion, so we're going to change that to reaction. And I think that that's reasonable, right? And then we have no idea where this goes from here. So we got an and A, we got an and B, we got an and C, and I gotta reprogram my brain to get back into chemistry. Took a couple days off, and now we're cooked. So and A, and B, and C, those make an atom. Okay. So proton, neutron, electron is my bet. Proton and neutron and electron smaller than atom. That's true because they make it, right? It's got to be proton, neutron, electron. I have a lot of faith in this. But let's keep figuring it out. One proton and one electron. Yeah, okay. I understand this. You are a proton. Yes, give me my conversation. Whoa, protons. I hope you're right. This is the neutrono. Yup. Come on, Acres. Neutron's the neutral particle, like Batista. Exactly. And then this is an electron. New log ready. Holy crap, we're just cranking along. Protons, neutrons, and electrons, we've got them all. Now it makes sense why the three were all defined in a single transmission. They're defining subatomic particles, all making sense for now. For now, let's continue. And then there's another one that's coming in, right? Yeah. I listen. Electrons, the smallest thing we've defined so far yet. Still takes up a frequency just like every other word. What does that mean? Not sure. I thought it sounded poetic. Maybe I should be a poet. Do not quit your day job. This is my day job. Okay, good. One proton, one electron make atom. One proton, one neutron, one electron make atom. One proton, two neutron, one electron make atom. 6 proton, 6 neutron, 6 electron make atom 6. That makes what the hell? I'm typing maton? That's just not even close to the right word. This makes carbon. I think carbon 6 or is carbon 8? No, oxygen's 8. I know these things. Okay, electron smaller. Did I really define not as exclamation point? I'm changing that back to not, man. So many you hate my stuff. And there's one person that has tried to convince me to change my negative to squiggly line like 100,000 times. I'm never doing it. I'm speaking directly to you now. It'll never happen. You cannot convince me to do that. That is not what that symbol means. Okay. Good. Very good. Yeah, very good. I think this is all fine. I think some of you told me get rid of the blob guy. Nah, you know what? Screw you guys. I'm putting it back. Some of you also were like, on these, you should do return before and after. No, that doesn't make any sense either, man. That doesn't make any freaking sense. You guys don't know what you're talking about, frankly. I think that I've got some good... I think my stuff makes a lot of sense. No space before, new line after. Unless you want... Do you want new line before on this guy? Because maybe that's reasonable. I think that's at least reasonable. I can mess with that. Okay, electron smaller proton, then proton. Electron smaller proton, then proton smaller not electron. What word do you want me to put here? It's not bigger. Although no, that doesn't make sense. Hold on. Electron smaller proton, then proton, Are you looking for this? No, okay. Then proton. Do you want neutron there? Proton and neutron is not. I don't. No. What the hell do you want here, man? I'm very confused by this. I get stuck on the easiest thing ever. Then proton. Proton, not. Electron, smaller proton. Are you just looking for an equals here? Then proton equals not electron? Yeah, okay, sure. That's fine. I can do that. I was good at what I did at the observatory at grad school. Yep, I'm not one to brag. Turning a new leaf, but I was pretty great actually. Wasn't just grunt work I did. I picked up on patterns. What if we start doing a Trump voice for Acres? We're like 11 episodes deep in this series, so I can start doing whatever the hell I want in these videos. I picked up on patterns. The younger a nebula, the higher its metallicity. Let's be fair, he can't pronounce that word anyway. Okay, yeah, we're not going to do that bit ever again. It measures the ratio of hydrogen and helium compared to every other element, metals to non-metals. That's what us astronomers care about when it comes to atoms. We keep it simple. If it ain't hydrogen or helium, it's metal to us. Drives chemists nuts. So a higher metallicity means less hydrogen and helium and more other elements. Right on, and hydrogen and helium are the elements with the lowest mass, which means a higher metallicity means a higher density. So I postulated that, okay, this is just a lot of words, man. Gravity is dependent on mass and distance. More mass and a smaller distance would mean gravity does its job all the merrier. Plus the star would have more fuel to start nuclear fusion, and then, whoa, slow down. It's been too long, way too long since I've been in an observatory, and I don't see that changing anytime soon. Okay, good talk. Proton area equals neutron area, and proton is not equal to neutron. Proton bigger than electron, then neutron not equal to... I think that I was not supposed to understand... Excuse me? Then neutron not equal electron. Excuse me? Why are they shifting between equals, not equals, equals not? Excuse me? Proton bigger electron. Then neutron area not equal. Is that what you're looking for? What are you talking about, man? Or neutron bigger. Maybe that's what you're looking for, is just a bigger here. The neutron's bigger. Yeah, okay, sure, whatever. All of the things I said were true, for the record, but... Dr. Akers, are you saying that you worked on their thesis for 4 years? That's thorough, to say the least. Nope, that was my PI's project. It was his research, his paper. I was the third author, which ain't bad, but you know how research goes. And how's that? Little red hen bakes the cake and then the PI eats it. Okay. This is atom 8, which would be oxygen. Which is good. That's good. A visual's available. That's exciting. Let's take a look at the visual. Okay. Carrie, I think he's finally off his rocker. Should we tell Doppler? Settle down, let's hear him out. In base 8, the digits 400 are equal to 256. It is the halfway point to 512, which is digits 1000. Oh, we're doing this again. I hate base 8. Why must you keep bringing us back to those dark times? Embrace the aliens. Think like the aliens. Okay. These sure feel like planets to me. No, they're just telling me a proton, neutron, electron. Yeah. Proton equals blob 2. Neutron equals blob 1. That means the blob 0 is an electron. Did I figure this out way earlier? I feel like it was straightforward that it was proton, neutron, electron, but Maybe I'm crazy. Okay. Now I have to start figuring out what atom this is. So there's 2 neutrons, 2 protons, 2 electrons. So this is an atom 2, also known as a helium atom. Blasting through. We're just blasting through. And we love that. That's a big one, man. That's a big one. Okay, you're going to be and A. And we're going to recompile you. So, and A equals atom. And A 1, 1 equals atom 1. And a 1, 1 neutron count is 0. This is an isotope, right? That's what this nonsense typically means. What are you doing? 8, 8, and 8. What element does this form? I've got a good guess. By the base 8 numbers, I'd guess that element 8 is their favorite. And maybe one of humanity's favorite elements, too. Yeah? So this... Go back to... physics? Isotope. Atom with a different number in neutrons. Are you an isotope, man? You could be, right? You definitely could be. Are they defined a certain way? So... I guess not necessarily. Unless it's their way of... So this would be the... Let's just see what you want from me, okay? And a 13. I mean, this is atom 13. I think this is an isotope. This is atom 23. I understand, I think. Whether it's an isotope or not, I'm not sure I care. Alan, I hope this isn't too forward, but I've been thinking about what you said. What you said about grad school, the research. Being third author on that paper seems to trouble you, maybe more than it should. And I'm no astronomer, but it sounds like an incredible paper. Something that you helped make possible. Shouldn't that be enough for you? Yeah, you're right. Journals loved it and it was highly cited, but that's not what people care about. They wanted to meet my PI, the one man behind it all, ask him every question and he'd have an answer. That's the thing. People just look for a face, a figurehead, someone to give all the credit. Someone to accept the prestige. That's, perhaps a troubling way to think, Alan. Yeah, I know. I shouldn't even care about all that fluff, that recognition. I know it should be about knowing my own skills, my own impact. But I don't know. Just don't feel it sometimes. Alright, man. Super depressing. So if you are a 1327, here's the thing though. If you're actually an isotope, I gotta look at the previous transmission. So this one here, neutron count is 0 here. Yeah, you've got to be an isotope, right? Let's try it. Do you like isotope? That's not how you spell that. That's isotype. Isotope? Yeah, you do like that. Okay, cool. Isotope works. Good. I will turn off log now. Okay. So when we're talking isotopes, so let's take a look at the periodic table for element number 13. You have an atomic mass of 27, which means that you have 13 protons? You have 13 protons. No, you have 13 protons. 14... You have 14 neutrons. Yeah, I mean, I understand-ish, I guess. Seems good enough to me. Yeah, seems good enough to me. Isotope count equals 2. Okay, I gotta look at the visual. Let's examine Mr. Visual. Oh, what the frick? Okay. Isotope count is 2. This is... It's hydrogen, right? Because we got 1 proton, 1 electron, and then 1 proton, 1 neutron, 1 electron. So this is atom 1, atom 1? Am I crazy? Because I don't know why that seems right to me. They're both atom 1. Idea available. I'll look at your idea, okay? Show me the money. Dr. Link, I'm seeing 2 different units in this image. I imagine we have to name them properly. One consists of 1 proton and 0 neutrons, while the other consists of 1 proton and 1 neutron. Yeah, but like... How do I define that? Because that would be... Isotope count is 2. I understand that this would be... Oh, I guess you're looking for... Okay, yeah. Hold on. So if we go back... I gotta see how they defined it in the transmission. So if we go back to here, this would be... Isotope 1, 0. Is this isotope 1, 0? 1, 0, comma, isotope 1, 1? I'm gonna tell you that does not seem right to me. But, because that second number is the number of electrons, man, not neutrons. So we'd have to include the count, right? So this would be neutron count equals 0. So this is a 1, 1, and then an isotope 1, 1 neutron count equals 1. Is that right? I feel like that's right, though. This is a matter of formatting. So we have... Look again at your transmission. Isotope 2356. Isotope 1, 1. Isotope 1, 1 neutron count equals 0. Okay, hold on. 1, 2. 1, 2 okay. So when we're looking at the visual, this is a 1. Look at your periodic table real quick. So isotope 1 if I then go here, yeah. So it's still called isotope 1. I wonder if the way that this works is it's defining... No, because that was defining the number of electrons, right? That when we're looking at these. So this is a 1, 1, 1, 1, 1, 2, though. Isotope. Isotope 1, 1 equals atom 1. Isotope 1, 1 with a neutron count 0. So no. This is the number isotope. This is the element. No. What? This is the element and then the isotope number. That's what it is. So this would be isotope 1, 1, and then isotope 1, 1, Isolate? My brain is not working this morning. Isotope 1, 2. Right? I actually feel good about that. Yeah. Okay, we figured it out. So the first number is element. Second number is what isotope it is. So what I really want to do, which you guys are gonna hate. You're gonna hate this. Isotope 4 elements. I can't make it that long. Isotope elements. Just to make this easier on myself. Alan, if you're sitting in this room with Batista, Dr. Olenki, and I, it means you're in good company. You're not here by mistake. People know your worth, the unique value you bring. Yes and no. People see that I'm good enough to get by. I'm starting to think that I'm kind of Alan in this YouTube series. I'm good enough to get by. And then all the comments are like, you don't deserve to be here. You don't deserve to be here. Even on the Apollo program, I did what I could to help, but they had enough astronomers telling them the flight path to the moon was clear, so you ran for coffee. Coffee, donuts, and later on some moon rock spectroscopy. A pretty robust background, ain't it? I would leave the first two off any resumes. You say that now, but just wait and see how good I am at my coffee runs. Coffee runs has a different connotation for me. Okay, Adam. Yeah. You have variable proton, variable neutron, variable electron. var 0 or var 1 or var 2. I have no clue what you are trying to tell me here. Is this a classic isotope element? Nope. Idea available. Yeah, because I have no idea what you're trying to tell me here. What is this one? I don't get the var in the mix there. We must fill in the question marks, and I suspect we do so with one of the 3 vars to choose from. Oh, yeah, okay. Fair enough. Yeah. So they're asking us the label for an atom based on the protons, neutrons, or electrons. 3 answers, just plug and chug. No, we must seek understanding or progression. Who cares? I think we're forgetting the route we take is up to Dr. Olenki. It's proton. I mean, that's very easy. I also completely screwed that up. It's definitely proton. That defines your element. I understand these things. New signal. Alan, you are insightful. You must know that. We need you for coffee. Batista. No, we need you to decode this message. It's probably been 2 months since I've last helped with anything. I hardly help solve the transmissions. I don't program our computer, and I don't do any linguistic analysis. But you start the discussion, Alan. You spark ideas. Even if you're wrong, you get us to think in a new way. I speak a lot, that's for certain. I suppose there's a minimal amount of help there, though I'd hardly call it expertise. Okay, yeah, hit the wrong button, for sure. Come back to my dictionary. Dictionario and Amy. I think you guys are gonna kill me if I keep this as isotope underscore element underscore, so... I'll recompile it, that's fine. I'll just learn what it means. Okay, so this is and A. Isotope 1,4. Let's take a look at our periodic table. So isotope 1,4 means it's the 4th. What? Is it actually the element? Hold on. Maybe I screwed this up. What are we trying to learn here? I have no idea what this is. Could this be chemical bonding now? Or could this now be a compound? Are you a compound? Nope, you hate me. Are you a bond? Are you bonding? Are you bondage? Okay, go back to your reference guide, please. Chemical compounds composed of atoms, individual instance. Could you be a chemical? Chemicals are made up of isotopes, right? That, Is that a thing? I don't know. Let's go back to calling you Ande for now. So isotope 1,4. The Ande equals 1 neutron. Plus isotope 1,3. So 1,4 plus 1,3. Is this charge? Is that what you're trying? No, that doesn't really make any sense. I don't think it's radioactive decay. I'm gonna be honest with you. I don't know. Maybe it is. Maybe it is, man. So a hydrogen atom with 3 neutrons decays. So this would be a hydrogen atom with you have 1 neutron. Is this decay? Let's try it. Decay. I don't know what this is, gamers. My chemistry knowledge ends here. That's tough. So 1,3 and A is 1 electron. It's you're adding. You're adding a. Yeah. Okay. Try not to understand this instead. I think this is kind of bonding, man. In some sense. So if I'm adding an electron to isotope 614, then this should be isotope 714. Is that right? Don't call me smart yet. Because I'm not positive I know what I'm doing. But we'll figure it out, I suppose, in the future. Give me the visual. We got some guys, okay? We got some lads. We have something and A equals 1 neutron. Isotope 1,3. So isotope 1,3 would be 1 hydrogen. And then 2 neutrons, because that's isotope 3 of hydrogen. So we are adding these together. So what does that do? I don't know. I don't know. I don't know what that does. If I'm adding another neutron, then this would be isotope 1,4. Okay. I guess I'm getting it right, but I don't necessarily think I understand it. Alan, the hydrogen line. Sorry, I took a sip of tea. Your undeserved silence for about 3 seconds. Oh, what? It's something you accomplish. You start the conversations, but if that's not enough, then look to the hydrogen line. The very first transmission, the basis for all frequencies we've received. I'm aware. If it weren't for you recognizing that specific frequency, would we be this far? We could have been stuck for weeks trying to deduce some meaning from those numbers, but you noticed the hydrogen line. You established our starting point. The aliens waved hello and you were there to see it. I know, it's been my pride and joy these past 4 months, but that's it. I'm running on fumes of achievements. We're a team, Alan. All this is your achievement. The hydrogen line is my achievement. That's all I have to hang my hat on. You must know that there was a reason Doppler wanted you for this mission. You know the universe better than any of us. Okay. Good. What do we got here? Proton reaction, electron reaction. I don't know. Neutron reaction? Reaction's not right. Although maybe it is. I don't know. I still kind of think this might be friggin' bonding, man. We're just gonna do it for now, okay? What do we got here? var 3 is var 0 divided by var 1. Okay, if you're doing actual math, we can figure out what the hell this is, man. We gotta be in physics. Is this decay now? Decay modes? No. This is half-life. It's half-life. It's half-life. Okay. Good. That helps. That helps a lot. So, let's dictionary. This is half-life. Do you want a damn underscore in it? I don't know. Let's just do that for now. So this is half-life. So if var 0 is 64, 64 divided by 64 is 1, and then 1 raised to the 0.5. I gotta pull the math out. 1 raised to the 0.5 times, which is 1, times 64. This should be 64. var 4 is 64. 64 for Olexa Kid 64. Excuse me? That's not right. var 0 divided by var 1. 64 divided by 64. Oh, sorry. 0.5 raised to the 1, which is 0.5. Times 64. This is 32. I read the math wrong. Because it's radioactive decay, man. It has to... Or half-life, whatever. It gets cut in half. This is just decay, really. I don't know. Or it's half-life. I don't know. I have something to say. Many years ago, my older brother played in the Los Angeles Philharmonic. In the orchestra? That sounds quite prestigious. He even became the third chair percussionist. So he invited the whole family to his debut with the orchestra. The first percussionist was standing with the snare drum, a triangle, and an array of other instruments. My brother was sitting 2 chairs over. He remained sitting for most of the performance. I thought back, at age 8, my brother was playing Beethoven on the piano. Come high school, he was first chair percussionist in the school band. Each time he visited from college, he showed me a new instrument he had learned. And now he was third chair in the entire symphony. Yet he was sitting. Nearly 10 minutes had passed and he had hardly played a single note. He hardly played at all that night. I'm sorry to hear that. Another passionate soul lost to the crowd. That is how I thought, at first. Though after some thinking, I realized it was all the part asked of him. That's the point. It's a shame to waste that, to waste such talent. He sounds like a brilliant performer. Symphony should have had him play more. Maybe. Maybe? Would the songs have been better if he played more notes? Okay. More Half-Life. That's fine. So, if var 3 equals 0, then var 4 equals 1. Is that true? 0 raised to the 0.5 has to be 0, and I can't believe I'm typing this into my calculator just to sanity check myself. 0 raised to the 0.5 is 0. Sorry, 0.5 raised to the 0, though, is 1. Yeah, I keep doing that completely backwards. And then if var 3 is 1, it's 0.5. If it's 2, it's yada, 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 yada. So if var 3 equals 8 raised to the 8, it doesn't matter. It will never be 0 because of decay. So this is true. It will always be greater than 0. It's just how decay. You can never... Half-life of an element never goes away. I understand these things. Okay. And Amy. Half-life is still correct here. I know I didn't get the clean, but that's fine. So, and A, var 0 divided by var 1, yada, 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 yada. So why is this... Maybe... Okay, try me one thing. Can I make this decay instead? Nope, you hate it. I'm making you Half-Life. And I'm adding my stupid thing. But there's also radioactive decay. Right? Is that what this is? I don't know. Isotope half-life, var 0. I don't know. I mean, this is just 0, I guess, but it's something we got to figure out here. I'm sure that it's not gonna get easier. X, Y, Z, and A. What? X, Y, Z, and A. It's time. Holy crap, it's time? Which actually makes so much sense. Yeah, that makes so much sense. Time? Time. Dr. Olenki, what do you mean? They mean time as a concept. Time. That which comes before and inevitably comes after, the independent variable of existence, the natural progression of matter in space. Okay, yeah, that's a sick one, man. Time's cool. That's such a good transition to understanding time, man. That's so smart. Okay. More Half-Life. I hate this already. So we know that var 3. So this is now radioactive decay. Let's pull up that radioactive decay. Because var 3 is your T over H. So isotope 2,6. var 1 equals var 5. Isotope 1125 var 1 equals var 6. Var 6 divided by var 5 is var 7. Var 7 rounded 3 times. Okay, you've gone a little too far, Meteorite. You've gone a little too far. I need to look at both of the ideas you've presented to me. What is this? Different isotopes, each undergoing half-life. Hold on, let me check our periodic table in the reference tab. Why? What are you searching for? It's just a hunch for now. Yeah, okay. That'll help a lot. We can figure this out. Found it? What is it? It's the half-lives in the reference tab. Check out the periodic table. I think it has to do with the half-life data of certain elements. Oh my goodness, good find. So how do we respond? By comparing the half-lives of the isotopes. It is a ratio they are expecting. So we got to divide one by the other. Do it, Dr. Olenki. Okay. Yeah. Yeah. So half-life of isotope 2,6. So reference chemistry, periodic table, isotope 2,6. That would be this, right? Is 0.806. I'm just doing this on my calculator on my phone. 0.806641. Okay. And then 1125. Reference chemistry, periodic table. 11 is sodium. 1125 is 59.16. So you're looking for rounded to 3 digits is 0.01? 0.01? That doesn't seem right to me. 0.013. You've given me an idea, which means that I was close. I just don't understand how to round. Or I needed to reverse them. Give me the idea, okay? I get you, or at least a little. None of this working. Why? We're doing something wrong. Thanks. Yeah, thanks. Hey, not conducive to problem solving? Okay. You have something? Divide the half-life of isotope 1125 by the half-life of isotope 2,6. And that's all? Likely. Okay, I did it in reverse. Go back. Go back. Actually, hold on. Can I... Is there a friggin' history in this thing? Yeah, there is a history in this thing. Okay. So it would be 59.16 divided by Nope. You can't see what I'm doing, but I promise you that it's not right. 0.806. 641. 73.3. Did we have that Backwards, 73.3, 3 digits. Yeah, okay. Good. Very good. 69 undefined. Sure is, man. Okay. What is 69 undefined? And A equals time count 1. This is a second. This is a second, man. There's no way... I'm going to tell you that I disagree with how the aliens live their life. The second, well, how do we know it's the same as our second? Yeah, exactly. I'm not sure. It seems to be based off of isotope 2.6. I'll dig through the reference tab. Maybe something will pop up. New log available already. Every time I'm like, this doesn't make sense, they literally prove me wrong. Oh no, what's wrong? It is a sad day. Batista, you too, what's wrong? Signals 67 and 68, we skipped them. Intriguing, but why sad? Unhappy dictionary, unhappy life. I forgot about you two and your bizarre rules. Okay, you're teaching me a second. We obviously don't know what their second is, but my guess is that their second is based off of the isotope, which means that 1 second could be... It could be like 0.806 or something like that. What is our visual, my gamers? We got all kinds of nonsense going on, okay? So we have isotope 2.6, which is helium-6. And you're just looking for something. Okay. Neutron count equals 3. Is that what you're looking for? Nope. I don't know what the hell you want from me, man. Isotope 2.6. I have no idea. I don't got a damn clue, to be honest. Isotope 2.6. What previous... Take a look at these, please. Second. Half-life. It's just that the isotope 2.6 that looks like this. Isotope 2.6. So, I mean, let's take a look at isotope 2.6. That seems reasonable. So that would be helium 6. 2.6 has 4 neutrons, though. So that visual does not have that. So this is not equal to that. This is just not. Because it doesn't have those neutrons. Okay, never mind. I guess I'm wrong. Right? That visual did not have... You got 1, 2, 3. And then you got this guy all the way over here. And 2.6 had 4 neutrons. I do not know what you are trying to tell me. Helium 2.6. Which is, this is the important one, man. They just said that this was important. Half-life 0.806 seconds. Isotope 2.6. I'd change not back to be not the exclamation point, right? Yeah, okay. Isotope 2.6. Could go back to in here. Isotope equals the image. Neutron count equals 3. Neutron count equals 3. Because there's only 3 neutrons in it. But it's supposed to be 4. So I mean, let's try that. No, you hate it. What do you want here, man? These are the tough ones when I can't even figure out what they want me to do with it. Do you want me to just put in a second? Because that's defining what a second is. Okay. Why go to there? Second equals time count 1. Like you're teaching time and then you just go back to an isotope. Could this be time? I feel like this is such an important one because there's something that I'm missing. Is there something in the reference tab? Speed of light. I feel like that could start to get somewhere, man. Isotope 2,6. 2,6 blah equals that. Isotope 2,6. But it's not isotope 2,6, man, because you are missing your neutron that's required. Unless you want me to subtract a neutron? Could that be the case? So this could be like, we would have to do BR and then 1 neutron minus. This doesn't make any sense for sure. Because that's just not even close to how the syntax would go. I always love when they don't give you frickin' anything. They give you the hardest thing ever, and then they give you nothing to go off of. So that was our second unhappy dictionary. And then we just know nothing. Well, I mean, look, good a place as any to stop for today. Thanks for watching. If you guys enjoyed, liking the video, much appreciated. I'll see you later. Have a good one. Bye-bye.